Assalamualaikum, good morning. So new chapter 6 is about chemical equilibrium. So in this topic we have point 1 dynamic equilibrium, 6.2 equilibrium constant. So for 6.2 we will have a lot of calculation. Okay, that one you will cover in your tutorial session. Okay, and last one 6.3 Le Chatelier principle. So for 6.1 in lecture we are going to explain what is reversible reaction, dynamic equilibrium and also law of mass action. Okay, so this one just untuk definition lah. Okay, and second one, okay, state the characteristic of a system in equilibrium. Okay, so how we know that the system is in equilibrium. So there are 4 characteristics. Okay, and last one, interpret the graph for concentration of reactant and product against times for a reversible reaction. Okay, so this one is a chemical reaction, okay, that we always refer A plus B. Okay, general reaction A plus B produce C plus D. Okay, for example, we have the reaction between methane and chlorine in the presence of UV, produce chloromethane and HCl. So this one we call as forward reaction. Okay, but most chemical reactions are reversible. So this sign refer to reversible reaction, meaning after A produce B, B will decompose to produce A. So when A and B react, so A and B are the reactants. Then it will go to forward reaction to produce C and D. So we call C and D are the product. Okay, when time increase, C and D will decompose, meaning dia akan terurai. So meaning dia akan pergi kepada backward. Okay, reverse reaction to produce back A and B. So you need common sense. So forward meaning left to right and backward refer to right to left. So reversible reaction meaning ada this sign forward and backward reaction. Okay, for example, we have this equation: SO2 react with oxygen to produce SO3. So when SO2 and oxygen react, SO3 will produce. Okay, as soon as some SO3 produced, so it will reverse, meaning the sum of SO3 will decompose to produce back SO2 and oxygen. So after a certain time, okay, when equilibrium is reached, so we say that the concentration for both reactant and product remain constant, so do not change. So at this condition, we say that SO2 and SO3 are in equilibrium. So what is dynamic equilibrium? So for reverse reaction, forward and reverse process continue indefinite action until the equilibrium reach. So this process we call as dynamic process or dynamic equilibrium. So we have 2 characteristics here to define the dynamic equilibrium condition. So at this point, okay, when dynamic equilibrium reach, reactant concentration for reactant and product are constant. Constant meaning remain unchanged, and the rate for forward and reverse reaction become equal. So concentration constant, rate equal. This general equation, A produce B. So from this graph, okay, initially a lot of A. So concentration of A is higher than B. So no B, meaning tak ada product lagi form. So when time increase, okay, moving to the right, so kita tengok concentration of A decrease. Okay, kepekatan untuk A iaitu reactant berkurang dan concentration of B will increase after a certain time. Okay, so certain time ni refer kepada this dotted line. So kita nampak dia punya garis dah jadi flat. So at this condition kita katakan the concentration remain unchanged. Okay, so at this condition we say that the equilibrium is reached. Okay, so this one refer kepada forward reaction. So forward reaction meaning A produce B. Okay, forward reaction. Okay, yang merah ni refer kepada reverse reaction. So bila A produce B, yang dotted red line ni, so initially we have a higher, this one is rate versus time. So rate for forward reaction, okay, meaning the production of B daripada A kepada B decrease bila time increase, but the rate for reverse reaction increase. But after certain time, so this one refer kepada sometimes ini T1 time. Okay, kita nampak garis tu dah flat. So after this time, the forward and reverse reaction are equal. So bila equal, line ni overlap. Okay, and concentration unchanged. Okay, tadi kita dah tengok untuk concentration. So yang ni kita tengok untuk rate. So rate equal, concentration constant ataupun unchanged. So at this condition, the equilibrium is reached. Okay, for example, we have N2O4. So N2O4 is colorless. So initially dalam kita punya bekas kita tak nampak ada colorless. So after a certain time, okay, on warming the N2O4, so dia akan change to gas. So when time increase, it will produce NO2. So NO2 kita nampak colornya brown. So color dia akan jadi brown daripada colorless. Okay, after certain time the color stop changing. Okay, so kita tahu pada keadaan tu rate of forward reaction equal to the rate of reverse reaction. Okay, this one is law of mass action, or we known as equilibrium law. So from this law, okay, it relate the concentration of reactant and product at equilibrium. For example, we have A react with B, produce C and D. Okay, yang A, B, C, D yang warna merah tu refer to the coefficient ataupun number of mole for the reactant and product. So according to the law of mass action, equilibrium condition is concentration. Okay, ini in expression of concentration of product to the power of its coefficient. So kita ada product C dengan D tadi daripada general equation A plus B produce C plus D. So we have yang small a, b, c, d ni ialah coefficient A, B, C and D. Okay, so from law of mass action, yang ni expression for equilibrium. Okay, K refer to constant equal to concentration. Okay, yang ini bracket ni refer to concentration. So concentration of product. So we have product C and D raised to the power of its coefficient. So coefficient kita ada C dengan D yang kecil ni over concentration of reactant. So reactant we have A and B, okay, to the power of its coefficient. So A kuasa A, B kuasa B. So the equilibrium constant expression is the ratio. Okay, ratio meaning divide by molar concentration of the product, to the molar concentration of reactant. So A and B are the reactant raised to the power of its coefficient. So kuasa setiap coefficient reactant dan produk tersebut. So for K will be constant at given temperature. Okay, and does not depends on the initial amount of reactant and product. So characteristic of a system in equilibrium. So we have closed system. Okay, when direction is occur, rate of forward and reverse are equal. This one yang tadi kita dah mention daripada graph. So properties such as concentration, pressure are constant. Okay, and final equilibrium position is the same. Akhirnya selepas reaction tu achieve equilibrium, dia akan sama. Tak kisahlah sama ada dia start daripada forward, daripada reactant ataupun dia start daripada product. Okay, so this one is summary from 6.1. Okay, define what is reversible reaction, define what is law of mass action. Okay, state two characteristic when we say the system is at equilibrium, and graph for concentration against time. So reversible reaction refer to chemical reaction that proceed in both forward and reverse direction. Law of mass action, relation between concentration of reactant and product at equilibrium. So two characteristic for dynamic equilibrium, rate forward and reverse are equal, and concentration for both reactant and product constant. So we have concentration versus time. So initially no product form, so zero product. So after a certain time, product will increase. Okay, initially we have a lot of reactant, so after certain time the reactant will decrease. At certain time, okay, contoh ini pada garis yang putus-putus ni, so concentration of product and reactant constant. Okay, meaning garis tu dah jadi flat.